So we are studying electrostatic potential. Electrostatic potential, or you can call it simply as potential. So actually हमने डिस्कस किया था कि पोटेंशियल क्या चीज है. So पोटेंशियल एक ऐसी टर्म है जो चार्ज के फ्लो है ना. ये जो पोटेंशियल है बेसिकली दिस इज द टर्म यूज फॉर फ्लो ऑफ चार्ज. ये फ्लो ऑफ चार्ज को डिफाइन करने के लिए यूज की जाने वाली टर्म है, फ्लो ऑफ चार्ज. सो हमने डिस्कस किया था कि the flow of liquid, the flow of gases. So the flow of gas that depends upon the temperature difference. The flow of heat, the flow of heat. So flow of heat के बारे में हमने डिस्कस किया था. Flow of heat that depends upon the temperature, you know, temperature difference between the 2 points. Temperature difference between the 2 points. हमने डिस्कस किया था फ्लो ऑफ लिक्विड, फ्लो ऑफ लिक्विड. So flow of liquid that will depend upon the difference in height of the 2 points. Difference in height of 2 points. Different in height of 2 points. And the flow of heat that depends on the temperature difference between 2 points. Between 2 points. So likewise, the flow of charge that depends upon the potential difference between the 2 points. Potential difference between 2 points. So our today's topic is find electrostatic potential. Electrostatic potential. Electrostatic potential of a point charge, point positive or negative charge at any point within its electric field, within its electric field E. So हमें एक पॉइंट चार्ज लेना है. वो पॉजिटिव चार्ज भी हो सकता है, वो नेगेटिव चार्ज भी हो सकता है, और उस पॉजिटिव या नेगेटिव चार्ज के कारण किसी पॉइंट पी पे हमें इलेक्ट्रिक पोटेंशियल फाइंड आउट करना है. ओके, सो लेट मी टेक ए पॉजिटिव चार्ज. So this is a positive charge and it is Q positive, and I choose a point P at a certain distance. So this is my point P at a distance X from the positive charge, and at this point P, I want to find out potential. So actual my target is to find out potential at P. So potential at P, this is my target. What is the potential at point P? So to find the potential at P, let me place a positive test charge at this point P at a distance X. So definitely what I will expect, this positive charge will apply a repulsive force in this direction. So this repulsive force, F repulsive, that will be there. Repulsive force will be there. And the magnitude of the repulsive force that will be equal to 1 upon 4 pi epsilon naught q naught upon x square. So this is the magnitude of the repulsive force between the test charge and this positive charge. So I want to find out the potential. I want to find out the potential at P. So because repulsive force is there on this test charge, so it means the test charge is placed within the electric field of this charge. So if I do one experiment, I want to move this positive charge. I want to move this positive charge plus q naught from this point P to a new point, to some new point A, which is at a distance, very small distance dx from P, and at a distance r from this, at a distance r from this real charge. So what I did, I just move the positive test charge from point P to a new point A, and the movement was, very small movement was dx. So when I did the small movement dx, so I moved just opposite to the force applied, repulsive force applied by this charge. So it means definitely I have to do a work against the repulsive force of this test charge. So what is that work? What is that work? So because the distance is small, so the work done that will be also be small, dw. Now first I will find out what is this dw. So this dw is equal to, because minus force into displacement. Why this negative sign is there? Why this negative sign? Because we are doing work against the repulsive force. Against the repulsive force. Our work done is against the repulsive force. We are moving opposite to the repulsive force. So that's why the work done is negative. So work done is negative means, when the work done is negative means we are applying external force. External force is there. We have to apply the external force against the repulsive force. So we have to apply the external force, so which is opposite to the repulsive force. So here the work done is negative. Now this is the repulsive force. Now I place the value of this repulsive force and I will find out the total work done also. So first I place the value of this force. So minus 1 upon 4 pi epsilon naught and q naught divided by x square, and this dx. Now I will find out the total work done. So I want to find out the total work done if I move the test charge from some outside point. Suppose the outside point is here. Outside point is here. It is at infinity. Now I take the point P at infinity, and I am moving the test charge from infinity to a distance r. Means I am shifting the point P to the point A, which is at a distance r from the charge. So I will apply the sign of integration. So sign of integration here, because 1 over 4 pi epsilon naught is fixed. 1 over 4 pi epsilon naught is fixed, and I will take this x square inside the because x square is variable. So this x square that will go inside the integration. So x square is inside the integration. So this is x square. Q is fixed, Q naught is fixed, 1 upon 4 pi epsilon naught already is, it's a fixed value. So I am moving from infinity, from infinity to R. So you see Now the point P is at infinity. The test charge is at infinity, and I want to move the test charge from infinity to this point A. So from infinity to R, because A is at a distance R from the this original charge. So limit क्या होगी हमारी from infinity to R. Now I will solve this integration, and the integration of dw, that is W, it is W is equal to minus 1 upon 4 pi epsilon naught, and this is q naught, and if I solve this integration, so it will become, I can write this from minus infinity to R, and I can take this x in the numerator, so it will become expressed with over 2 into dx. Now I will solve this integration. I will solve this integration separately over here. So separately I try to solve this integration, and finally after solving I will put the value, so I will put the value over here. This is x raised to the power minus 2 into dx. So what is the integration? I can write that x raised to the power minus 2 plus 1 minus 2 plus 1, because in the integration power is incremented by 1, and then in the denominator we will write the same power minus 2 plus 1 within the limit minus infinity to R. So what is my integration? So it becomes x raised to the power minus 1 divided by minus 1, and within the limit infinity to R. So I can place the values. I can take this minus sign outside. So this will become 1 upon x, and limits are infinity to R. So now I can write minus sign outside, and I can write 1 upon R minus 1 upon infinity. This minus sign outside, this is 1 upon R, and 1 upon infinity, it becomes 0. So we are left with only minus 1 upon R. Now place the value of minus 1 upon R in this equation over here. Place the value over here. So what I get? What I get? W is equal to, so W is equal to minus 1 upon 4 pi epsilon naught q naught, and this is minus 1 upon R. So this minus and this minus, they become plus. So W is equal to 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught q naught divided by R. So this is the work done in moving a test charge from infinity to a distance R. So let me write this. This is the work done in moving a test charge from infinity. What is the meaning of infinity over here? Infinity means any point outside the electric field. Infinity means the point, a point outside the electric field. आउटसाइड द इलेक्ट्रिक फील्ड, जहां पे कोई चार्ज का, जहां पे इस पॉजिटिव चार्ज का कोई रिपल्शन नहीं होगा, सो दैट इज कॉल्ड द इन्फिनिटी. ओके, वो बाउंड्री लाइन पे एक पॉइंट होगा जहां पे इस चार्ज का कोई रिपल्सिव फोर्स नहीं होगा, सो दैट इज कॉल्ड इन्फिनिटी. सो उस बाउंड्री लाइन के, इलेक्ट्रिक फील्ड के जस्ट बाहर के पॉइंट पे हमने एक पॉजिटिव टेस्ट चार्ज रखा, और उसके बाद हम उस पॉजिटिव टेस्ट चार्ज को r डिस्टेंस पे लेके आएंगे. सो उसके लिए हमने जो वर्क किया, दैट इज W. So what is this W? So this is the work done. This is the work done in moving a test charge plus Q naught from infinity to R. Means from P to the new point A. A is at R and P is at infinity. Okay, so this is the work done, and we also know that the potential is equal to W upon Q naught. Potential is a work done on a test charge. What is potential? Potential is work done on a test charge. So place the value of W over here. So we will get 1 upon 4 pi epsilon naught q naught upon r, it is r, and here I have in the denominator this q naught, so 1 upon q naught, so this q naught is cancelled. So finally v is equal to 1 upon 4 pi epsilon naught q upon r. So this is the potential of a positive charge. This is my positive charge. So if we are asked to find out the potential due to a negative charge, so potential due to a positive charge is positive, but if we are asked to find out potential due to a negative charge, so potential due to a negative charge, that will be 1 upon 4 pi epsilon naught minus q upon r. So the potential due to a negative charge is negative. So we have two potential. One is the positive potential due to a positive charge, and other is the negative potential due to a negative charge. So from this equation, we can say that the potential is inversely proportional to r. But we also know that in case of electric field, at a point, electric field was inversely proportional to 1 upon r square. So this is the difference between potential and electric field. Potential of a positive charge is inversely proportional to r, and electric field of a charge is inversely proportional to 1 over r square. So if we plot a graph, between electric field potential or distance. So in case of electric field, what we are getting this type of graph. Okay, in case of electric field, we are getting E is inversely proportional to 1 over r square. We are getting this type of graph. But in case of potential, we are getting this type of graph. The graph will start, and this will be the graph. EV is inversely proportional to R. So let me plot this again, because this line should not touch this line. So let me just plot it again. Let me plot this again. So first I plot for V is inversely proportional to R. So V is inversely proportional to R. I will plot like this. V is inversely proportional to R. Okay. And so this is V is inversely proportional to R. But when I plot E is inversely proportional to 1 upon R square, then the graph will be like this. Okay, so this will be the graph. So actual graph is this. Okay. So there is some problem in my pen. Okay, so let me go to the there is some problem in the pen. Okay, so let me go to the main slide. The main slide of potential. Okay, so Anjali, slide is visible or not? अंजलि,
Yes, sir.
स्लाइड विजिबल है ना?
Yes,
Okay.
sir.
So this is my final result. This is my final result. VR is equal to 1 upon 4 pi epsilon naught Q upon R. Okay, so electrostatic potential due to a point charge VR is equal to 1 upon 4 pi epsilon naught. So we can write electric potential which is inversely proportional to R. Okay. So now we have some points which are to be noted. So I discussed that the first point is that if we have a positive charge, then the potential is positive, V is positive, and it is equal to 1 upon 4 pi epsilon naught Q plus, because it is a positive charge, Q plus upon R. But if we have a negative charge, the potential is negative. For a negative charge, the potential is negative, and that negative potential is equal to minus 1 upon 4 pi epsilon naught Q upon R, because the charge is negative. Here the charge is positive. This charge is negative, so that's why potential is negative. Now the third point is, what is the meaning of negative potential and positive potential? So V negative means, V positive means, what is the meaning of V positive? V positive means work will have to be done by external agent. Work has to be done, it is a external work, क्योंकि हमें अपने पॉजिटिव चार्ज को इलेक्ट्रिक फील्ड में P से किसी पॉइंट A तक मूव कराने के लिए एक्सटर्नल वर्क करना पड़ेगा. सो एक्सटर्नल वर्क है, इसका मतलब एक्सटर्नल वर्क है, सो एक्सटर्नल फोर्स भी है, एक्सटर्नल फोर्स भी है. इसका मतलब क्या हुआ कि इलेक्ट्रिक फील्ड ने कोई वर्क नहीं किया, ये एक्सटर्नल वर्क करना पड़ा, इलेक्ट्रिक फील्ड ने कोई वर्क नहीं किया. Okay, so it means no work done by electric field. Electric field का यहाँ पे कोई work done नहीं हुआ. No work done by the electric field. But if the potential is negative, negative potential क्या होगा? जब ये हमारा पॉजिटिव चार्ज है Q, और यहाँ से x डिस्टेंस पे किसी पॉइंट P पे हमने एक माइनस Q यहाँ पे चार्ज प्लेस किया. अब जब माइनस Q प्लेस किया तो ऑलरेडी ये जो प्लस है इसको अट्रैक्ट करेगा, सो खुद इसका अट्रैक्टिव वर्क होगा, खुद अट्रैक्टिव फोर्स होगी, तो इसका मतलब क्या होगा, यहाँ पे खुद इलेक्ट्रिक फील्ड काम कर रहा है, इलेक्ट्रिक फील्ड ने अपना इलेक्ट्रिक वर्क किया, इलेक्ट्रिक फोर्स लगी है. सो इट मीन्स जो वर्क होगा वो बाय द इलेक्ट्रिक फील्ड होगा, इलेक्ट्रिक फील्ड का वर्क डन होगा, बाय द इलेक्ट्रिक फील्ड होगा. जो फोर्स भी होगी वो इलेक्ट्रिक फोर्स होगी, है ना. सो यहाँ पे क्या हुआ, वर्क इज डन बाय द इलेक्ट्रिक फील्ड, वर्क इज डन बाय इलेक्ट्रिक फील्ड E. तो ये वही इलेक्ट्रिक फील्ड है जिसमें हमने अपने चार्जेस को प्लेस किया है. एंड द नेक्स्ट पॉइंट इज दैट, द फिफ्थ पॉइंट इज दैट potential, whether it is positive or it is negative, it is a scalar quantity, it is scalar, because the potential, it defines the flow of charge, or it defines the flow of energy. flow of charge को डिफाइन करेगा, और फ्लो ऑफ एनर्जी को डिफाइन करेगा, फ्लो ऑफ, बिकॉज चार्ज इज एनर्जी, फ्लो ऑफ एनर्जी को डिफाइन करेगा. एंड एनर्जी इज स्केलर, सो द बिकॉज potential defines the energy, because energy is scalar, so potential is also scalar. But electric field is a vector, it is a vector. So why it is a vector? Because electric field that define force, Force is a vector, so that's why the electric field is a vector. Now the second point is, so point number 7, I write the point number 7, the point 7, potential is the property of a point in the electrostatic field. So potential is the property of the point, property of the point, and our point was point P. So potential is the property of the point P in the electric field, in the electric field. So because it is a property of a point, so ये एक किसी पॉइंट की प्रॉपर्टी है, ये किसी पॉइंट पे एनर्जी का फ्लो है, किसी पॉइंट पे एनर्जी का फ्लो है. सो हम यहाँ पे यूज करते हैं एक नई टर्म पोटेंशियल के लिए. पोटेंशियल इज माइक्रोस्कोपिक क्वांटिटी, बिकॉज ये किसी पॉइंट की प्रॉपर्टी है, ये किसी पॉइंट पे चार्ज का फ्लो है, ये किसी पॉइंट पे एनर्जी का फ्लो है. सो पोटेंशियल V is a microscopic quantity. It is a microscopic quantity. So these are the different points, important point about the potential. So potential is inversely proportional to R. Potential is classified as positive potential or negative potential. Positive potential means work is done from the external agent. Force is applied by the external agent so that the charge can move within the electric field against the repulsive force of the charge. And if the potential is negative, it means work itself is done by the electric field. Work itself is done by the electric charge. Force is electric force, and potential is a scalar quantity because it defines the flow of energy. It defines the flow of charge because energy is scalar. So that's why the potential is scalar. Electric field, it defines the force between the two charges. So that's why it is a vector quantity. And potential is the property of a point. It is a characteristic of a point. At that point, we define the flow of charge. At that point, we define the flow of energy. So that's why the potential is called the microscopic quantity. Okay, Anjali, that's all for today.
Yes, sir.
Okay, bye.
Thank you, sir.
Okay.